All right, so where we kind of left off on part C, we're asked to write an equation of a line using the equation provided in part B. In part B, we were given points. Out of the 2 points that we wrote down, do you like 0, -3, or do you like 2, 0? Okay, either one will give you the same conclusion. The information that you know is the slope. The information you need to know, and it'll make a note at the end of this lesson. So you can write a note here. To write a vector equation for a parametric situation, it is going to be x, y. So there's our first vector. It's going to equal x1, y1 plus a, b times time. So this is where we get our time equations. I don't know if we wrote this last time or not, did we? Okay, perfect. Okay. So when we label all this information, this is your x1, y1, and then the slope is your b over a. So once you have a point and a slope, you can then basically just plug it to this equation. So this will then become xy equals 2, 0 plus 2, 3 time. And there you go. There's your vector equation. Any questions on that? Go ahead. Positive? It doesn't have to. You could use 0, -3 as well. No, I should have crossed somewhere over here on this right side. So it should be there are 2 or 0, -3. Yeah, no, it doesn't have to be positive. Whatever the coordinate is.
So the 2, 3.
Because the equation is a b, the vector. The formula for slope is b over a. Just remember, in slope, this is the change in divided by the change of x. So when I do this, this needs to associate with my x, when this needs to associate with my y. So if my slope is 3/2, it becomes 2/3 as a vector. Okay. So that's the question. Any others? So know this equation, and then know how to plug it in. All you need is a point and a slope. If you have that information, you can write parametric equations for a linear function. So to write this as a parametric equation, you're just going to write it out as an equation. And if you can't see, this is a parametric equation, meaning x equals 2 plus 2t. And the other one would just be y equals 0 plus 3t. Do I really need that 0 though? No, so I'm just going to simplify it real quick. So I'm just going to rewrite it. So what a parametric equation does, if it's any on part E here, we're going to verify this algebraically by doing that table I started showing y'all. So I'm going to write E here, but I'm going to write it up a little bit higher. So this will be my E. You probably have enough room on your E. I just don't feel like scrolling down. So I'm going to do my table. So I'm going to do T, X, Y. And really and truly, I'm going to write like an X comma Y to represent this coordinate. All right, so I'm just going to do a few. So I'm going to do 0 seconds, 1 second, 2 seconds. You can kind of keep going forward. Directions might tell you to do. You can illustrate however many that is. So what I do is I take this time, and since both of these equations both have an equation with time, I'm going to take these values and plug it into each one of these t's to work out the answer as a coordinate. That means this will now be 2 plus 2 times 0. What's 2 times 0? And then what's 0 plus 2? 2. Before we go on to the y equation, any questions on how I just got to this point? So the equation we just formed as a parametric, and I'm just plugging in time. So at 0 seconds, my x value was 2. Right now, we're just verifying that these parametric equations do, in fact, graph the linear line that you did on part A. This is just verifying that what I just wrote out actually does do what I asked it does. Bless you. So take your y here. I'm going to do the same thing. 3 times 0 gives me 0. There's your coordinate, 2, 0. So go to your graph on 1A, 2, 0 fall on that line. Yes, right, it's from the line we just took. Maybe that was a coincidence. Maybe it's because it's supposed to work that out. So let's do another one. Let's now do 2 plus 2 times 1. What's 2 times 1? Plus 4. And then this would be 3 times 1. So what's 3 times 1? 3. What's that coordinate? 4, 3. Does 4, 3 fall on your line? It looks like it does. Maybe we're just a really bad drawer, right? So maybe it could look for me off a little bit. We can verify if it truly is. So here's a little side question. What was the equation you got in A or B or whatever? Because what was it? 3 over 2x minus 3? Was that the equation from 1A? Yeah. So take this equation. If it ends up being a true statement, then it's a point that would fall on that line regardless if you're a bad artist. Y in the 3, that's what I calculated, equals 3 halves times 4. That's what I calculated for my x. It's 3. What's 3 halves of 4? It gives you 6. All right, we plug in 2. What's 2 times 2? Plus 2? 6. Very good. You're good. 3 times 2? So this gives me 6, 6. So again, I can verify again. Let's do this again. What is 3 halves times 6? 9. Very good. 2 goes into 6 3 times. 3 is 9. It's 9 minus 3. 6. So again, that point would fall in. You can keep verifying that or have a nice drawing of a graph, but there you go. So we do, in fact, algebraically, these equations work. Okay. So what this is doing for us, if we're given an equation, of course we could. Sometimes I can give you parametric equations that would want one of two things: graph a linear line. Is the equation of the line the parametric equation? So let's look on to the next example. Question so far. So on part 2, Olivia wrote parametric equations xt equals 4 plus 2t and yt equals 3 plus 3t. Right, Olivia? Are her equations correct? Were those the equations that we just got? So does that mean that she's wrong? How can we check? Just plug it in. Now I'm going to show you a different way because it's going to approach number 3 or 4. But if I want to know if Olivia is correct with these equations, here's the first step you want to do. Take the x equation. So here's the first step. Solve for t. How would I solve for t here? -2. Oh. -4. I always want to get rid of the constant first, the coefficient. So I'm going to subtract 4. So I get x -4 equals 2t. What do I do to get by itself? Divide everything by 2. Now I'm going to rewrite x over 2 as 1/2 x. Are we okay with that? It just looks clean. You can if you want. 4 divided by 2 gives me 2. And now I have t. So step 1, the x equation solved. Any confusions on how to solve for t? It's typically going to be 1 to 2 steps. Subtract, divide by whatever the coefficient is for functions. Parametric equations can get a little harder when we're talking about quadratics, circles, hyperbolas, exponential equations, things like that. But for these 2 lessons here, we're just really focused on linear functions. Make sure you understand parametric equations as a whole. Step 2. You're going to take this t equation you just got, and you're going to plug it in for the t of the y equation. By doing this, you will develop a y equals mx plus b equation, and we can judge that to our 1a and see if it's the same equation or not, to see if Olivia is correct. So again, this will now be y equals 3 plus 3. Again, replacing the t with this equation. So when I replace something, I always use parentheses to indicate multiplication. 1/2 minus 2. Before I move on to the solving or simplifying part, any questions on how to just plug in? Okay. How do I simplify this then? Right, we got to distribute, then we'll combine like terms. We got to get rid of the parentheses first. What's 3 times 1/2 x? Keep it as a, and you're correct, yes. But keep it a fractional form. 3 over 2. So 3 halves, 1.5, same concept. The only reason I say leave it as an number so that it can potentially look like our problem on 1a. -2, -6. Next step is now to combine like terms. Again, I'm trying to write this as y equals mx plus b, so I am going to write the mx part first, and then I'll combine like terms. So what's 3 minus 6? Get 3. Was this the equation that you got on 1a? Yes. So believe it or not, there are infinitely many ways to write that equation for the exact same linear line. Doesn't mean all answers are true, but there is an infinite amount of them. What's on that process? So it's pretty straightforward. Take the x equation, solve for t, then take that equation, plug it, simplify. Number 3. Convert this parametric equation that's to you as I do apologize for this lecture being so boring. I still yawning and falling asleep, but let's talk about it. In part 1, we just showing you that this parametric equations work. The gist of this lecture is this right here. What's that? Yeah. So I need that right there. So is this concept slide down to y equals Do, do, do. If you got two fractions as part of your answer, you did it correct. Yeah. It's not like an ugly fraction, but there are two fractions. It's not like, 289 over 17 or something crazy like that. So I like to think it's clean-ish. Well, I guess that would be pretty subjective, huh? Yeah. Like you could probably easily simplify this in your head as a mixed fraction, give or take. Right? Do some long division. I like it. Because math. Are you ready to check it? I'll give you some more time. Oh, we can't be stuck with fractions. All right, let's start with step one. What's step one? Figure out your t from the x equation. Now, this is very specific when trying to write it as slope-intercept form. Theoretically, you can actually solve this for an x equation with y in it versus y equation with an x in it, but y'all don't know how to graph those yet. That's something you'll learn either in college pre-calc or in calculus. Maybe we can go a step further in it as well. These calculators that you have in front of your desk don't do relations, so they have to be in y equals form, but they can all be expressed both ways. I'll give you the same credit after you just got different parameters when it comes to your domain and range. Regardless, I'm going to take my x equals 2 minus 3t. How do I solve? Good. We get rid of that constant first. So x minus 2 equals negative 3t. Good. I'm going to divide every single term by negative 3. Now, again, I'm going to rewrite this because it just looks cleaner, in my opinion, to say negative 1/3 x. Negative 2 divided by negative 3 would give me positive 2/3. Very good. That would go away. There's your t. I now have an equation for t. What do I do with that? Plug it in. So everyone was good at this point, but then when we plugged in, the fractions came in and man, those darn fractions. A -2 and a -3 will produce a positive 2/3. If the denominator and the numerator are both negative, it'll always be a positive. All right, so now this comes y equals 4 plus, I'm going to plug in my t. So that's going to be negative 1/3 x plus 2/3. I have nothing to distribute. That's why I didn't use parentheses. But if you did, there's nothing wrong with that. The next step, you would just drop the parentheses. Now, from this point, what's the only thing I can really do here? Combine like terms. So when I go here, I get negative 1. Oh, too many negatives. Negative 1/3 x. And then what is 4 plus 2/3? 14/3. You either typed it in the calculator or you can see that 4 is the same thing as 12 over 3. And then 12 over 3 plus 2 over 3 gives you the 14/3. Whichever path you go. If you're confused on why this is 12 over 3, you just multiply 4 times 3 and it gives you 12. And then basically 12 divided by 3 goes back to 4. So it's just turn it into an improper fraction. Because they have to have the same denominator to add. Yeah, absolutely. Any questions there? So now you produced a linear equation given both parametric equations. This is really the hot topic in pre-cal. It's turning a parametric equation back into a regular equation and then vice versa, taking this and turning it into the parametric equations like we did on 2 or 1C or 1D or whatever. So we go forwards and backwards. So we're good with all that? Yes. All right, let's look at 4 and 5. Information can be expressed to you differently, and it can be expressed to you in 3 dimensions. So on 4 and 5, you're presented with this information. You are asked to write out the parametric equation given a point in 3-dimensional space and given a 3-dimensional vector. Just like the 2-dimensional equation, it is still going to be x, y, z equals x1, y1, z1 plus a, b, c times t. Right? The only difference between a 2-dimensional and 3-dimensional is we just have a z equation as well. Other than that, it's the same process. Same concept if you were going 4th dimensions, 5th dimensions, or anything like that. When you're given a coordinate as a point, notice this is in parentheses. This would be your x1, y1, z1. If you're given a vector versus given a slope, a vector will tell you that this is the A, the B, and the C, representing the change in both the X, the Y, and the Z. All right, we're good there? Good. So vector would tell you the direction, which is what slope tells you. That's it. So when we plug it in, this is what your parametric equation will start off as. X, Y, Z equals 4, 2, 9 plus 2, -1, 3, t. Is everyone good with this point? This is not the final answer, but this is the answer that will give you the final answer. I might have. I did. I did mean to put -3. Thank you. Any other issues? All right, from that, just like in 1C or 1D, I'm going to write these out as 3 separate equations to make it look like this guy right here. So this becomes now x equals 4 plus 2t. What would the next equation be then? Perfect. How can I simplify that? How can I simplify it even more? 2 minus t. Right? If you wrote it as plus -1t, you're not incorrect. Just know on the test, it's going to simplify it down to minus t. What would the z1 be? Good, I like it. You already changed it to a minus rather than saying plus -3. Again, you're not incorrect by saying plus negative. It's just not how it's going to be presented to you on the test. Questions on how to write parametric equations. You basically just form 3 equations in respect to time for the change of x, y, and z. All right. Now, from that, you also have to be able to go from this back to, I believe it's this form. So I got to go backwards. All right. So for a vector form equation, that would be these vectors here. It's going to simply be this. So it's going to be, again, using this equation. So it's going to be x, y, z. To find the coordinates, the point here is going to be the numbers that basically don't have a t attached. So on x, is there a number that does not have a t attached to it? So what would that represent? 0. What would be my y? -4. What would be my z? 3. Good. So those right there, these numbers here represent the point that was used. So when I come over here, I'd write it out as 0, -4, 3. Plus the slope for each t per each equation. So what's the a in x? Or the number next to t? Good, 3. What would the b be in y? What would the c be in z? -1. Very good. And then you just write the t. Go ahead. So the point, this point right here, is typically the number that's being added. So it does not have a t attached to it. So when I look at this first equation, what number is not attached to t? Look at the x equation. Which number? There's not one. So when there's not one, there's a 0. Because I could technically say this is 0 plus 3t, and then 0 would be the starting x1 value for x. And when I come here, this -4 is not touching t, so that's the starting, that's the y1 point, so that goes there. And then my z would be 3, that would be the starting z1 point before it got affected by the slope of time. Any questions there? All right, if you were to continue on in your notes, everything that we've written down is nice, neat, and organized for you in this lesson summary. They don't always give us a lesson summary, but this one is a really good one. So for two-dimensional space, highlight that equation so that you can turn that equation into this equation. All right, so very important. And then same concept for three-dimensional space. Here's the vector equation that will get you to the parametrics equations. So these three things, very important. All right, I would also note, I don't know if it said it in there. It does. I would highlight this as well. If given the slope, it's b over a, so plug it in accordingly. But if you're given the vectors, they give you the slope as is. Right? So highlight those things. If you continue on to the lesson summary right there. Any questions on lesson 21? Again, those are nice and neat just in case maybe you didn't write it, or maybe you just don't trust your handwriting like me. Lesson 22 is where we're going to go to next, and it's actually just a continuation of this. It's like more problems that you could potentially see. So what I want you to do for the next 2.5 minutes, do that open-end exercise AB. Find the parametric equation given the point and the vector for both two-dimensional and three-dimensional. So go ahead and practice what we just did in that opening exercise. There's only like 3 exercises in this one. If I could get it all done. Yes, ma'am? Correct. Yeah. The only time you have to flip the A and B is if you're given the slope. If it gives you the vector, it's in the correct order already. One thing that does get tricky on this stuff is knowing what they're asking for. Remember, parametric equations wants them as x equals y equals z equals. Vector equation is the one where it has the xy equals x1 y1 plus ab times t. So know the difference between parametric equations and the vector equations, because that gets a little confusing.
So the vector that they give you is the AB?
Yes, sir. Because remember, vectors give you not only distance, but direction. That's what slope does. Slope gives us direction. We can do it right now. We got 2 minutes. Are we ready? Does everyone get an opportunity? I'll give you 20 more seconds. You say what? Take your law degree. Yeah. Hmm? You don't have to put a 1, no. Oh, yeah. Yeah, then you do put a 1. Yes, I thought you meant 1 times t. You do not put a 1. But if it's 1 plus t, the 1's there. You don't need the 0. If it's 0 plus something, you don't have to write that. Yeah, that's a good point. All right, so here's the equations if you don't know it. So it'd be x, y, written out as 1, 1, plus -2, 3, t, which then turns into x equals 1 minus 2t, and y equals 1 plus 3t. Any questions on that? Okay. This one here would be x, y, z equals x1. Oh, well, I'll just go ahead and write them. You already have the equations. This would be 2, 3, 1 plus 4, 1, -1 t, which then gives us x equals 2 plus 4t, y equals 3 plus t, and z equals 1 minus t. We good? All right, y'all enjoy the rest of the day, guys.